All right, there are a few requests about the solution to question number 2 and question number 4. So we're going to start with number 2, part 1. The start vertex is what we use to initialize the set O, and we can see how it starts with vertex A. So we know vertex A is the start vertex. Part 2, what is the destination? So the thing about the destination is as soon as the destination is figure out, or at least we find a path to the destination, then the g value and the f value of the destination would be the same because the heuristic from the destination to itself is going to be 0. So that's a huge clue, because when we look at vertex B, J, Q, one of them is likely to be the destination, and we can see that B has the same g value as its f value, so it is certainly eligible to be the destination. And then we look at the other two. The other one is J. J has a g value of 34, and it has an f value of 45, so it cannot be the destination because these two values are different. And then Q is kind of in the same boat because Q has a g value of 41 and the f value of 44, so it cannot be the destination either. So that's how we can decide that. I just noticed that the mouse pointer is not captured in the video. Anyway, but you can still see it, even when I mention those things. So on the last row, by the time we get to the last row, only vertex B has the same value, has the same g value as its f value, and that's how we can conclude that vertex B is the destination. All right, part 3. Identify all the edges and determine their distances. Note that this may be a subset of the actual set of edges, and so on. So that's pretty easy because we look at outgoing edges. The algorithm explores all outgoing edges. So AP is an outgoing edge, AB is an outgoing edge, PM is an outgoing edge, PJ is an outgoing edge, MQ is also an outgoing edge. But we can only see those edges. We cannot see maybe some of the additional outgoing edges because they were never explored. Okay, and determine the distances. Okay, so the distance is determined because of the way t is calculated. Because t is the g value of c plus the distance from A to P. So at the point when we look at the first time we update the value of g of P, we can see how g of A at that time is a 0. And that's also how we can tell that A is the start vertex. And we can see how the t value is 19. So 19 is the distance of the edge AP. So all of these are deduced from the algorithm itself. And then part 4 says determine the heuristic value. And the heuristic value, by definition, is the difference between the f value and the g value. So that's how we can determine the heuristic value of vertex P to the destination is 3, because we can see how the g and the f value are different by 3, and so on. So that's how we answer all the parts, or so far, all the parts of question number 2. Question number 4 is about Dijkstra's algorithm. Figure out the set of destination S. Okay, so the destination, so let me highlight this. Okay, highlighting actually shows that that's helpful. So the destination is how Q is initialized. So that's how we can determine that vertex P and vertex B are the destinations. The second part, and determine the distance function as much as possible. So in this case, the distance function is indicated by the L value. When we explored R, okay, let me highlight and see if I can highlight it. Yeah, there you go. So when we explore R as an incoming neighbor of P, the way we updated the L value is 31, and this 31 is the distance of the edge RP plus the L value of P itself, which is 0. So that means 31 minus 0 is 31. So 31 is the distance from R to P. And I'll pick another random example here, maybe this one here. So we updated the L value of A to be 17 at this point. And then at that point, the L value of Q is a 7. The difference is 10, and that's how we can determine the distance of the edge AQ is a 10. So that answers the distance function part. Okay, so I'm highlighting this portion here. In each part of your answer, explain the reasoning. So I just explained that using the algorithm itself. So basically everything is in the algorithm itself. It is a question of how do you make use of the algorithm in conjunction with what is in the trace table that is already provided to you. In summary, your answer, whether it is in a set membership format or a visual diagram format, should include the following. The set of all the vertices, that's like super duper easy, because basically if you make a union out of all the Q's, that's pretty much the best you can do, because that's okay. That it goes on longer, but just to make a union of all the instances of Q, and those are the vertices that we can possibly encounter in the original graph. And then the edges are the ones going from W to V, and those are the only ones we can figure out. There might be some additional edges that we did not end up traversing, but those because the trace does not contain those, so that's not much we can do about it. And then the distances is based on how we update the L value, as I talked about a little bit earlier. So every time we update the L value, we can, in fact, okay, every time we update the L value, we can figure out the distance of the edge from W to V, because that's how the new L value is calculated. So those are all coming from the algorithm, and I think that's pretty much the full explanation of how to answer questions number 2 and 4. Basically, everything boils down to the algorithm itself, and this is also why I said in class, being able to mechanically trace the algorithm is only half the story, because you kind of have to understand how the algorithm, why the algorithm works in the first place. That is the part that can help you kind of answer these questions. Okay, so I hope this is helpful.